Hello everyone. In this lecture, let us learn how the programming works about image segmentation. So, for this operation, let us import our OpenCV2 library and also import NumPy as NP. Now, we have to read in an image. So, let us create a variable called img, and inside this, using cv2.imread, let us read in an image. I will be reading in the scenery.png image. Now that we have finished reading in our image, let us convert our image into the RGB color space. So to do this, I'm using a variable called img_RGB. This is equal to cv2.cvt color. Within brackets, I'm giving img, cv2 dot color underscore bgr to RGB. So now I have converted my image from BGR to RGB. So now let us go ahead and reshape our image. So let's create a variable called img underscore res for reshape, and this is going to be equal to img underscore RGB dot reshape. Why are we using img underscore RGB? Because for this process, I have to be using the color converted image. So over here, I'm going to give the values -1, 3. We will be converting the image into a 2D shape. Okay. So now let us run this code. The next step is to float convert our image. So now we will be converting the 2D data type into a float. So for this, we will use the variable, let's call it as vec, and using np.float32, I will be passing in the variable img underscore res. So after float conversion, we have to create our termination criteria for the algorithm. This means that the program will stop if this particular criteria is met. So what is this criteria, and when all should the program stop? The program should stop if no cluster assignment occurs, or the number of iterations has been reached, or if the epsilon value is lesser than the specified value. So let our termination criteria be called crit, and inside this I'm going to be assigning the cv2 dot term underscore criteria underscore eps plus cv2 dot term underscore criteria underscore max underscore iter. Now I have to enter two more datas. The first is the number of iterations. So let us set the number of iterations to, let's say, 1000. This value is being set by me. You guys, after the session, can go ahead, change the number of iterations and the epsilon values and other values as I mentioned down the lecture. Along with this, let us also set the epsilon value to 0.2. So let's run this to make sure there is no error. So now let us create the k-means cluster for us. So let us set the number of clusters as k and let the value be set as 3. Then let the number of attempts be set as, let's say, 10. So now for the clustering, here I am going to create three variables called ret, labels and center using the cv2.kmeans function, I'm going to be doing the k-means clustering. This will take in 6 arguments. Okay, the first argument is going to be our sample image. The sample image we are going to be giving is the image after float conversion. So I have to give vec over here. Next, it is followed by the number of clusters, which is k. Next, as we don't need to store any input or output integer for the clusters, we will be providing the keyword none over here. Now, the fourth argument will be the termination criteria. So, our variable is crit. This is then followed by the number of attempts. This is the number of times the algorithm is going to be executed. So, the variable for number of attempts for us is attempts. Last but not the least is the flag. This will specify how the initial centers is to be taken. We will be using cv2.k-means underscore random centers as our flag. The cv2.k-means function returns the compactness, that is, the sum of the square distances, a label array, and the array of cluster centers. Now that we have finished the k-means clustering, we have to carry out unit clustering. This is nothing but converting the array of cluster centers into 8-bit. So let's create a variable called center and assign np.uint8, and the argument is going to be center. Now we will be converting the pixels to the centroid color and make it a single array. So let us first create a variable called img underscore seg, and inside this we will be setting center label dot flatten. This label dot flatten should be inside square brackets. Let us now reshape our image underscore seg to our original image. So img underscore seg will be equal to img underscore seg dot reshape, and inside this you're going to give img dot shape, that is the shape of our original image. So the mistake I made over here is, in my k-means clustering I gave the label array name as labels, but over here I simply type the name as label. So now let us create the code for displaying the original and the segmented image. So as you can see, I have created the code for displaying the segmented and the original image. So let's run it and see our output. So as you can see, on the left is my original image and on my right is my segmented image. So the output can be seen in which all colors has been segmented as per our input image. There are a number of things you guys can play around and change with. For starters, you guys can change the number of iteration and the epsilon value. Next, you guys can change the number of clusters as well as the number of attempts for the algorithm to be run. You can also create a loop that is an incremental for loop for checking the output for different cluster values. So why don't you guys go ahead and try these out. Thank you. See you guys in the next lecture.